Yo, 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 what's up? Good morning, good morning. Good morning, Geralt. Hope you had a wonderful weekend. So I'm back after a unfortunate break. I think I only did 2 streams last week. I had uh, some work was done in my apartment complex, so I didn't have power for one day, didn't have internet for 2 days, stuff like that. But hopefully, I've set up a goal that we're gonna close off the tessellation today or tomorrow, so I really want to get this done. I think it's apparent by now that we can't do it exactly as I would want to do it. So we're gonna try and find a middle ground. So I'm gonna do, I think I have 2 approaches today I want to test, and I just want to measure them real quick. We're not going to do any in-depth performance testing and such, but I just want to measure the performances and what kind of visual clarity we can get. So basically, my first approach is going to be to work with the quad mesh we have. We're going to tessellate the quad mesh and so on and so on. But then after the tessellation, we're going to send it down to a geometry shader that just splits it like this. And this is, so basically we send down a triangle and we just want to split it like this, which means that we're going to redo this middle point, but I think it will be all right. So that's the first thing we're going to try, and I'm going to try and build this shader in such a way that we can flag if we want to include a split or not. The second approach is we're going to take a step back and rely more on the tessellation itself. So we're going to go with the triangle mesh, and we're going to go with tessellation that is not integer nor how-to, which means that we get this a way more type of dynamic tessellation. I will show what I mean when we get there. And if we calculate the normals correct and the height differences correct by doing this, I think we can get a really nice result with not too much sliding, hopefully. But the biggest problem with that solution is that, so like I've been positive, or what I've been wanting to produce here is a mesh that tessellates in such a way that we never lose or change information, i.e. the middle of this triangle will still be in the middle of a sub-triangle when we tessellate it. And I want to achieve that because I also want to use this, whatever solution we get to, I want to use that tessellation solution together with the ground and grass material, and to implement proper LOD fading with the grass, we need to always spawn the grass in the middle of a triangle, and the center of that triangle can never change position, basically. But yeah, okay, so we have 2 approaches I want to test today. And we will see what it results in. I'm a little bit afraid that, like, we do the tessellation down to this part, but as soon as we introduce the geometry shader, we're gonna see quite a drop in performance, but we'll see. So what we have here is this one we can disable. I think we want to go with original here. Or actually, is it this one? Terrain, tessellation, quad, test material, test quad. think it's test quad we want to go with. Let's see if we can play this. There we have it. So it's actually, yeah, test quad, here we go. So we're gonna start with this one, but we're gonna do, let's see here, 1, 1. We're gonna change all of these tessellations in uniform, so we always get this. And then right here, we're gonna split this one here and here. I think this is gonna work. So then we're gonna have, I don't think we're gonna go 3 actually. No, we're never gonna go 3. So we're gonna go 1, 2, 4, 8, and so on. So this, and then for each quad here, we tessellate it like this. And then we do 8. And on it goes. Okay. And what material is this? Terrain tessellation quad test material. Yo, what's up John Olsen? Vill du själv ha koda? Today it looks like that, over on YouTube at least. I'm gonna do tessellation amount pow, and if this one is bigger than 0, we're just gonna override these. So I wanna do, and yeah, let's take these. What do we? Wanna do this? Yeah, let's try it. So if this one is 0, we rely on all of these. If this one is greater than 1, we do this one. And then we go like this. Actually, 1, 2 to the power of... Wait, this is not what I want. We wanna do how to integer. Donaldson ringd ljud. I think we should have sound. One sec. I'm getting the correct feedback at least. Two to the power tessellation amount power. What am I missing here? We should be getting, when we tessellate more here, we should see this one should split into 4 quads. We should go 1, 2, 4, and so on. 1, 2. I'm getting a no sound notification over on YouTube. You people watching on Twitch, do you hear any sound? Do you hear? Catboy King, what's up, by the way? I hope you had a great weekend. Thank you for answering, Catboy King. Appreciate it. I can hear you on YouTube and Twitch. Thank you. Appreciate it. Okay, so this is what we should see. 1, 2. Oh, yeah. I know why. We need to do this as well. 2 to the power of, and we want to do round. There we go. So now we're back at this solution. That's great. So let's see if we can add a flag. I want to add a flag that is split or no split. If we have split, we're going to split each quad into... It's basically, I want to add more control. John Olson works now. Nice, great to hear. I want to add more control over how we triangulate these quads. Because we basically want a cut through here as well. So we're gonna do that. We're gonna do a quick check on how much we degrade our performance. And if it isn't too bad, we are gonna add a deformation to it as well, do some normal recalculations and stuff like that. Catboy King, okay, going back to bed. Enjoy that bed. Yo, what's up, Jax? How long have you been working on this prototype? You can probably see it by my YouTube videos, but I think I wrote my first line of code in the end of 21, probably. So let's split these and see what we get. Although I do want to... We're going to disable this one. We're just going to play around with this one. And then I wonder if we want to change. I'm going to put the camera around here, I think. Like that. Okay. So let's see if we have terrain procedural snow. Actually, we're going to do it like this. Normal texture flag. Split flag. And we just do if and if. Okay, great. So basically what I want to do here is I want to add a geometry shader between domain and fragment, which means that the input of the fragment can sometimes be domain shader output, and sometimes it's going to be geometry shader output. So what I'm going to do instead is we're going to rename it. It's going to be a little bit messy. Let's see here. But we're going to have struct fragment shader input. We're still going to have domain shader output. Let's see. Domain, domain, domain. Okay, this should be pretty easy. We're going to do it like this. It's just else. So if we have a split flag and we do, oh, fuck me. Actually, we can probably go with wonder if we can do this. Let's try it. Can learn something new. I wonder if we can have this one as fragment shader input. And then if we have the flag set, we just take this fragment shader input and change it a bit in the geometry shader and outputs it as a fragment shader input as well. Let's try it. But we also need to do split flag. We want to do here. If def, and we do like this. Mm-hmm. Mm-hmm. Okay, let's see. And we're always gonna we can easily calculate how many vertices we're gonna return. We're always gonna return 4 vertices, 2 triangles. I would love to be able to use adjacent here. Then we're gonna call it fragment shader input, and we're always gonna get 3 points here. In out triangle stream. So this is what I'm wondering. Are we gonna be able to? We'll see. Okay, first of all, I'm just gonna see if this works we're gonna do I'm just gonna initially we're just gonna do this. Output stream append input 0. One, 2. We get 3 points and we just output 3 points. We get a triangle, we output a triangle. Redefinition of float 4. Main shader output, yes. We have extra split on quads is not. Did not find shader kernel geometry. Can't we do... Can't we define it like this? If we were to do this... Then we get the full one, okay. But I would like to be able to do this and still get my result. This might be... I will see. Did not find shader kernel geometry because we don't define it. If def split flag and if def split flag and if. It's good to know that this and this works. We can take fragment shader input and return fragment shader input. This one. To remove one sec. And we have this one defined before we use it here. Basically what I as I understand it, what we're getting right now is that we compile, or this part, if split flag is enabled, we include this. If it's not, we exclude it. This part right here, however, seems to be included no matter what. Yes. That sucks. I wonder if we can do... What do we have here? Okay, yeah, this one seems like we can't... If we write it like this one is included no matter what. So let's do HLSL exclude header kernel flag. Is it even possible? CMake, no. Okay. Any way around this? Let's get back to that one at a later point. Because what I want to do now is... I want to assign these points some color data in the geometry shader. I want to see what kind of result we get. When we introduce a geometry shader, we're probably going to get a split between... So for this quad, for instance, this is one triangle. Although in the initial mesh, this triangle shares 2 points with this triangle, I think we're going to get a split here, or a seam, when we introduce the geometry shader. I want to just see if that is true, and I also want to see if we can find some pattern, like when we have triangles like this, which has a 90-degree angle at one corner at each point, I wonder if there's some structure to the numbering of the vertices. So will this vertex at the 90-degree corner always be vertex 0 or 1 or 2 for each of the triangles? So what I want to do is I want to add a float for color here. And then down in the geometry shader, we're gonna do we're gonna do this. Let's see. We have position, clip space. Let's name them like this. Output 0. Zero, 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 zero. Really? Or is that old? And then in the fragment shader, I want to return input color instead. Yeah, I don't think we can find anything out from this. Or at least not find what I do want to find. Lou. Nah, okay. So we're gonna have to do some checks here. We're pretty much gonna have to... We want to identify this one right here. This one is always gonna have a length that is bigger than these two. So we could do something with that. Although I wonder... Or actually... That would be... I think we would add a redundant amount of calculations. What we can do instead is we can do comparisons. So we take point 0 and 1, point 1 and 2, and point 2 and 0, and check all of those. Like for this line, we have the same x coordinate. For this line, we have the same y coordinate. while this one has a different x and y for both points. And then we're also going to have to double check how we want to construct the triangle strip, or in what order we should add the vertices to create a correct triangle strip that goes like that splits this triangle in the middle right here. But let's see. Okay, I think we can identify correct one pretty easily. Let's see. Or actually, instead of identifying this and this point, we can just identify this point and this point. Because then we know that the other two are the ones that creates the diagonal line. I wonder which is the easier option or the better option. Can do if input 0, dot position, world space dot x is not equal to input 1 dot position world space dot x, and let's do this. Right, so if we take 2 points, take 2 points for this triangle, we take this point and this point, they have the same x, so it's not those two. This point and this one, they have the same y. This one and this one, opposite x, or different x, different y. Then I guess we're gonna have to do it like if 0, 1, 2, 3. Now let's take a look at triangle strip HLSL. One, two, three, four. So we want to do like this. So I guess we want to do so 3 goes back to 1. So 1, 2, 3, 4 should be it. 1, 2, 3, 4. Actually, that's not entirely true. 1, 2, 3. That goes back to that one. So 1, 1, 2, 3, 4. Can we even do it like... Okay, V2 is the one that is connected to 3 other points. So it's very important that we make this one V2. V1, 2, 3, 4. I reckon. So V2 has to be the new one. And then I wonder if we want to get the correct normal of it. We don't want to backface cull some of it. The order of the other ones, it's going to be too important. It's going to be important to us. But okay, let's do this. Let's just try and do... P2, actually we're going to do it like this. P0, input 0. E2, input 1, E3, input 2. P1 then is going to be P1 dot position. World space is equal to lerp. What's up, cooler? SK. Something like this, and then I also want to do dot color is equal to wonder if we can do it like this, and then we do, so here we do 1, 1, 2, 2, 2, 2, 0, 0. And then just, let's do E0. Let's try this. Lerp. Oh, yeah. Wrong. We should we should see something like this for all of them. I would have hoped. Don't we have any selection wire for this one anymore? Why do we lose the selection wire? Okay, that explains it. Yeah, this is fucked. Okay. Oof, 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 oof. Okay, so what we're gonna have to do, the order here, we're gonna have to change this one. So what do we have? We can have this. This. Can we have 4 different? So what we want to do is, we always want this one to be P1, and we always want this one to be P0, I think. So wherever we find the diagonal, we have to order it after that. So if we do first, second, third, fourth. Okay. So we get the 2 points that create the diagonal line. We set the first point to always be the first, this one second, the one that is not in the diagonal as the third, and this one as the fourth. So that would be P0, 0, correct. And then we set 2, 1 for this one. And here we have between 1 and 2, so we do P0 is 1. P1 is this one. P2 is 0. And this one is 2. And then here we have between 2 and 0. So 2, 0. Maybe. Works for this, works for this. Here we actually get the wrong cut here. Because 0, 1, 1, 2, 2, 0. Do we have floating point issues, floating point errors we need to take into account here? Possibly. Compare with error. We could possibly improve this one even more later on if we split. And we'll see, we'll see. Let's do a comparison with error, see if it's a floating point issue. But, we should be able to compare something that is way more precise than world position, and because we have done a lot of comparisons with the UVs earlier, and we don't have a floating point error there. So I wonder if we want to do... Domain, we get a UV here. Yeah, let's just send this one in, I think. Let's try with that one first. So we do... Oh, never mind. I know what the error is, by the way. Why? If we do sed... This one right here, what do we have? Layer loop. Is it our scripts? What the fuck? Is execute render graph. Just wonder why this one peaks here. I would have guessed shadows. Main light shadow. Why the fuck does our main light shadow peak like this? if it were a garbage collector, if it was a garbage collector spike, much like this one, I would fully understand it, but this... Main light shadow. What the fuck happened there? Jag måste till lektionen. What the fuck? Now it's not main light shadow. Here we have garbage collector, right? Wait for last station and update time. What does it collect? What does it collect in this scene? I have no idea. Oops. We don't use any custom render features. I don't really see how this is a problem caused. Oh, actually. Is that so? No, it's the garbage collector. Editor loop, I don't care about the editor loop. Oh well. I just want to see, I want to try and identify if we get any peaks like this from, like if any peak is related in some way to what we're doing right here. What the fuck did we have there? I don't think so, but... Garbage collector, and here we have editor loop. Okay. I think we're okay so far. We can see these drops. I don't think they're related to this unless we actually do this. And this. Yo, what's up, Fabic? Hope you had a wonderful weekend. Use deep profile for this. Yeah, like... one sec. Just have to figure out what that is first. Like the thing is, oh yeah. We're gonna do some proper performance analysis eventually, but right now I just wanna. We're doing some experimental stuff. I just want to make sure that nothing we do right now fucks us up too much. Deep profiler, yeah, we're gonna check that out eventually. You're talking about this one. Why would I have to instrument all scripting method calls to investigate scripts? So do we just... Does this one just... Does this just analyze the scripts we're having? So I'm talking about like CPU. Deep profile unity. Do we have deep here? Okay, like this is extremely useful. Thank you for mentioning this. I had no idea. But just in our case, like right now, the only thing we are changing right now are shader stuff. So deep profile would not give us any more information about the things we have changed, but we would get more information about the garbage collector, right? So yeah, okay. So you're spot on that, and I appreciate it. So when we want to double check the garbage collector, which I'm very interested in as well, in this empty scene, we could enable deep profile. You learn something new every day, definitely. Then we have disable other to show, to not show editor usage. Where do we have that? Because, okay, basically what we have here is an empty scene. We have basic geometry that is being tessellated a lot, and then geometry processed by a geometry shader. We get pretty consistent around 300. We dip down at certain points. Those points are either editor related or garbage collector related. Very interested in. So if we take a look at this profiler, this one right here. So if we want to get to the bottom of this one, garbage collector 44% makes it peak. We can enable deep profile, and it would analyze all of the C# scripts, right? Or mono behaviors. We would get way more detailed information about that. But this is just a... This is just a classical garbage collector pass, right? No matter, like, this will be done... We're just doing the default garbage collector, so this will be done even if we don't have any garbage, right? Profiler. But okay. Profiler disable the other. There we go. That one right there was the shadow. Here we have garbage collector. Garbage collector. I could see. There we go. This one. Render pipeline, and I guess this is the shadow calculation, right? Initialize frame. Hmm. That's our garbage collector again, right? Garbage collector. Fuck. Wait for percent. Hmm. That was a non-garbage collector related peak. Okay, by doing a very half-assed analyzation here, I think we can at least say that, yeah, we could go down a little here, but this one is not cause for any big change yet. Okay, so let's see what we have now. If we take a look at this mesh, don't we have selection wire? What? So this is like, this is the end topology I would like to get. I think it's beautiful, and we're gonna get, we're not gonna get nearly, and I don't think we're gonna have any jagged edges like we did previously with this one. So we're gonna start deforming this, but also, so basically what we do now is that we tessellate as quads, and at the end of the tessellation we have something like this. We split it into triangles and we send it to the geometry shader. The only thing the geometry shader does right now is that it splits this diagonal line, adds a point, so we add a point, and like this. So it splits 2 triangles into 4 triangles, basically. I wonder, in my end solution, I would probably like to have the next tessellation step should be handled in the geometry shader. So if the tessellation just tessellates, and whatever it tessellates is set, we don't, how should I explain this to make it clear what I mean? So when we move towards a mesh, we tessellate it more and more and more, right? We tessellate it more and more and more, right? If we want to avoid popping, we're going to have to do some interpolation with the tessellation, because otherwise when we go from one tessellation level to another, we get this, instantly we get more detail, so it pops in. So what we've done previously is we identify the vertices in the tessellation shader that has recently been added, so the most recent subdivision number, and then we fade those vertices to their goal position. That fading part and stuff like that, I wonder if we want to take that and we don't do it in the tessellation shaders, we do it in the geometry shader. So if we get sent this to the geometry shader, we do the last bit of subdivision there. So instead of just adding this one right here, I'm thinking of doing, we add that one, but we also add this and this, but then we're gonna have to add this, this, and this as well. Which means that we're gonna get 3 points. Is this correct? Yeah, I think so. We're gonna get 3 points that we pretty much calculate 2 times. If we take a look at the other triangle, which creates this initial quad, like, I think this might be a pretty good solution if we want, when we want the result we do. So here, if we take a look at this point, this point, this point, we already have these points, but they don't know about each other. So for each quad that consists of, what is this going to be? 1, 2, 3, 4, 5, 6, 7, 8, 16 triangles. So for each quad that consists of 16 triangles, we are gonna have 3 duplicates, but I think that's okay. And the good thing when we do these calculations here is that it should be okay. But so the tessellation, it only does tessellation. We take a lot of its calculations and move them to the geometry shader instead. So in the geometry shader, we know that the most recent subdivision, so the vertices we should fade in instead of pop in, are the ones that are new for the geometry shader. So that is, I think this is the closest to a good solution we have come in the last 2 weeks, maybe. This one is new, 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 and this one is new. And actually, we're gonna have duplicates here, and we're gonna have, however this one is, we're gonna have duplicates here. So out of the 16 points, we have 5 duplicates, but I think that's okay. We can experiment a bit with this, but I think it's good. Although I also wonder, I'm gonna implement a normal calculation utility file as well, because we're gonna calculate our normals in a lot of different ways. I want to test the performance. So given a point we deform, we've done this multiple times. When we recalculate the normal, we can either take these neighbors, so that's one way to do it. We can also add the connected neighbors, but if we want the best result, we can also add these. But okay, let's start by offsetting this one. Although I wonder, yeah, let's do textures, environment, terrain textures. What do we have here? Yeah, we just have this one. Okay. So let's do, how big do we want to go here? Let's try 1024 times 1024. Do we want Maybe we want to go 8, 8, or is that too much? This is probably good. Black low, white high. I'm starting to get some of this optimism back for the first time in a while. I think this might result in something very nice that can be reused for both the ground and the water as well. I want to avoid normal calculations, and I want to avoid quad flipping on the CPU for as long as we can. I'm just gonna call. Did we already have displace test, by the way? Displace, yeah, we had this one. Save this one as terrain test height map. Okay, there we go. And I want to check. So we want to add a texture here, and we want to offset the vertices based on those textures. We are actually gonna... So we're gonna have some logic still in... So when we do the tessellation, we still want to offset these points. So when it gets sent down to the geometry shader, we actually have this point, and this point offsetted with the correct normals as well. Yes. We're not... So if we take a look at this one, if we go with a connected vertices... we'll see. But I wonder, like, so for these new points we generate here, we're gonna have to calculate a position that is we're gonna have to calculate a start position and a end position, and then we're gonna interpolate between those two depending on how close the camera is. When we calculate the start position, I think we only want to do it based on the initial connected vertices. So it's going to be this one and this one. Fabic, have to go, Robin. Hope to catch you later. Thank you for dropping by and learning, educating me on the deep profiler, by the way. I appreciate it. Have a great one, Fabic. Okay, so this is initially going to be quite messy. But we're going to do it slow, experiment, and like as I said, I'm quite optimistic about this in one way or another, I think we're gonna get what we do want to get. And I also have to say that this, whatever we do now, is a solution that works for a wide range of graphic cards. Yeah, sure, we exclude some of them by introducing the geometry shader. But, as I've said, this is probably what I eventually would like to do, utilize a mesh shader. But if we do that, we're going to exclude a lot of graphic cards. But yeah. Okay, so one step at a time. We're going to start by introducing the height map, and then we're going to do some offsetting of vertices. We're going to start by just offsetting the vertices in the tessellation shader. But I wonder, what do we have here? Util terrain data. If we could do it without the branch as well, it would be amazing. Fuck, we could probably sort it. We'll get to it. Okay, so in the domain shader, I want to offset this one in the height, and we want to calculate this one as well. Normal. Normal VS. I don't think we even care about normal tangent. We can keep them around, but... So what I want to do here is... Let's see... Okay, first of all, we're going to do this. 1. I think we want to do like that. And I always forget the new way of doing it, so terrain base data. This, yes. Texture 2D height map. And then I wonder, point lamp. No, I'm pretty sure we want to go by linear. So we're gonna start by doing in domain shader here, position world space. We skip normal for now. And we do float height is equal to height map sample level, height map bilinear lamp sampler UV level 0. We have this UV, it's domain location, so this is the UV that gets calculated during tessellation. So let's say that we on the CPU we create a 2x2 quad setup, so we eventually have 4 quads, and we want the UV to go from 0 to 1 for this full initial mesh. What we get down here is a UV that goes between 0 and 1, but only for the sub-quads, pretty much sub-quads created on the CPU. So we would like to do... Are we gonna have to test quad, edit script? We do actually create the UVs, so that's great. So we can do vertex shader input, float to UV text chord. Then we just send it onwards. Here. Here, I think. We don't need it here just yet. Here we do float to position. Oh, let's do it like this. we want to use this one here. So, but what do I want to call it? We use UV interpolated here height, and then we just do plus ler 0 max height 8. Let's see. E. Something like that. Oh yeah, of course. But then again, yeah. Now we can bring this down a bit. Holy shit. Interesting. What did I fuck up? If we do 0 here, then we get this. Okay. T height, yeah. Plus float 3, 0, 0. One. Okay. Right, and then we also we don't want to work with clip space position here right now, but we can do it. Okay, this one is 1k times 1k. We don't have nearly enough vertices right now, and I also find what we want to focus on here right now is the middle points here. How do they deform? Right now we just lerp them to their connected vertices. So this one right here actually got lerped according to this one. So the height of this one is based on the middle height of this and this. Eventually we're going to read these heights ourselves. But let's see, I want to deform it more and more and more. So we don't even have, when it comes to these middle points, I do think they do already affect the silhouette over our deformation, but not in the most optimal way. So I would say, I don't know if we have a perfect example of this right here, but it would definitely have been a bit more jagged at certain points if we did not have the middle points. Okay. And if we don't have normals, we don't get very good visual of it without the wireframe. But this one right here, yeah, this one right here we can improve. Actually, yeah, this one right here. I wonder though, where did this one get its height from? It is probably, yeah, okay, so it's this one we should have deformed. But that makes me wonder. I want to get a smoother silhouette of this. This is pretty cool. But before we do anything else, I think we're gonna implement some normal calculations here. And this time around, we're gonna implement... we're gonna implement all of these methods in each in their own function. I don't think it will be that much code writing. We can just copy and paste from our various solutions, but it's just nice to have it in one file. So I think we're gonna do it like this. Let's see. Shaders, util. I think we're gonna do it like float 3. Float 2 UV center. Yeah, float 2 UV step. I don't know if we want to keep this one as UV. I don't know if we want to keep UV step as a float 2. We might always go with this, just a float. And then we want to send in whatever the texture is. I guess we can't use sampler either. No. I don't want to work with nested for loops here, so we're probably just gonna do float. Okay, so when we calculate the normals, it's also very important that we keep the ratio. When we read from the texture, we get a normalized value between 0 and 1. When we calculate the normals, if we want to get a good result, we need to have the, depending on what space we calculate the normals in. I wonder... Because, okay, let's say that we calculate the normals in world space. Then it's very important that the height we read, that one is in world space if our distance to neighbors is in world space. We could, if we have a sync, if we know that the max height is always the same as the full texture height dimensions in world space, then we could probably calculate it in UV space, but so let's do it like this. Start with the texture, and then we do UV, but we name it center UV, step UV, step UV, step world space, and I want to say height world space. But we would like, I mean, the best would probably be to have height and step in object space instead of world space. But we want to work with world space when we exit vertex shader, I think. So all depends on how we do this one. I think. Could probably do like this as well, but we're gonna read one extra. Yeah, so we do it like this. Or calculate normal from texture. And then we wanna have 3 different methods here. We wanna have one that is, where do we have settings? Low quality, high quality, medium, low, medium, high. Start with this one. And do I have... Where do we have it? We probably had it around here. This one works if we know with the what which vertices that are the connected ones. This time around we don't. Yeah, it's the medium one that is going to be hard because we don't know if our quad is split bottom left to top right or if it's split top left to bottom right. So we're gonna rely on let's do this one for now and see what we get. Low quality. So we want to do float. Yeah, we're gonna do it like this right now. Float 3. Yo, what's up, Spires? Thank you for the raid. I appreciate it. Have a good one. So we just want to recreate left, right, up, and down, and then we just do a simple cross product. Although I wonder... Yeah, I think. So let's do up is equal to... Zero. This is where we want the height. So text, sample. And then we want the flow or the UV. And we want to go center UV.x, center UV.y plus step UV, right? And we also need to set the sample level, which is 0. And this is the up point, so we move upwards in the Z direction. So here we also set step world space. But that is not all. We also need to do whatever value we get from the texture sample, we do height ds multiplied with that one. A little bit of a mess. We move we only move upwards. So 0 in x, the height is this multiplied by whatever value we have. Yeah. Down very similar, except that we do minus step vs and minus step uv. And we do right. Minus and minus. If we send in the correct values here for step in world space, it should be okay. And then finally we can just return cross between left minus right and minus down is this. Let's see what we get with this one. Fragment shader input. So here we want to send calculate normal from texture low quality. And we want to send in the texture first. Height map. What did we call height map bilinear clamp sampler? And what did we have? Center UV, step UV. Center UV then would be UV interpolated. Step UV. Yes. Okay, so now we're getting to the very important values, but a bit more complicated values to get right. So step UV and step world space needs to sync. And when I say that they need to sync, I mean in a way that when we do one step in the texture, the distance we step there needs to be equal to the distance we would step in world space. we can, so usually what we do here is, let's see. So we need to send down to the shader how big in world space is our mesh, and then we can calculate, so our UVs are in between 0 and 1. We can calculate the UV step size by just doing 1 divided by the dimension of the texture. And then we multiply that with the full size of the mesh, right? But we can also choose to do this a little bit more complicated, which would give us some better results. So let's see if I can draw this and in a way that makes it apparent what I mean. Let's change this background to gray and let's rely on the grid. Okay, let's say that this is our height map. Each square here represents 1 pixel in the height map. And let's say, so if the tessellation amount and the height map dimensions sync, that means that for every point in the mesh, or that every point in the mesh is going to be located in the middle of a height map pixel. Probably have something like this. So when we calculate the normal for this point, if we do UV step that is 1 pixel, we get this one, and we calculate them okay, and so on. But since we have like a dynamic tessellation level on this, there might exist a case where we have quads that look like is this a square? We might have quads that looks like this. That's not very nice. Something like this. So if we were to, whatever. If we were to calculate the normal for this point, going the default route, we would take this one, this one, and this one, and this one. This is the easy way. But we would actually possibly... Would we? I'm wondering if we would actually like to calculate our normal based on these points. We could do this in a nice way. We could fade out. Okay, this is definitely what we're gonna do in the end to get the best result, because when we look at the mesh from a very, very, very far distance, we don't care that much about perfect normals being calculated. Instead, what we would like is mean normals, and we can do this like we tessellate our mesh in such a way that we always it's the power of 2-ish, or 2 to the power of x, And if we know that the lowest levels sync with the texture, we can just downsample the texture. We can use the MIPS. But okay, initially, we're just going to do this solution. Okay, so we need form mesh properties. Dimension. So what we can do here before we call this one is float step UV is equal to don't we have this information? Maybe we don't. Do we have texture 2D? Let's add it. So then we do step UV is equal to 1 divided by, we're gonna assume that X and Y are the same sizes. So height map size.x. And then we do step UV float step world space is equal to step UV times dimension. So then a height map, UV interpolated. What more do we have? Center UV, UV interpolated, step UV, step UV, step world space, height world space. Here we just do max height. Something like that. Normal world space. Start by just lerping the... So for our newly generated points in the geometry shader, we just lerp the normal. And we want to use the normal as well. I wonder... I forget, let's just output it initially. See what we have. Okay. Incorrect number of arguments. Load, float, load. Oh, did I screw this up here? Float re 0. Really? Then we get it wrong here. Okay. No. Might have screwed this one up. Let's take a look. Sample level. Hmm. Hmm. X sample level. We want 3 here. We want the sampler. a UV and level. What am I missing here? Yes, I'm missing that we want to specify the channel here. We're reading a 4-channel texture, so we get RGBA here, and we want... It doesn't really matter. So R. Something like this. Now we have it at 10. Yeah, we did. Now we get it here. Because we don't want R. We don't want R here. We want R here. Valid subscript normal VS. Output normal VS. What are we working with here? Fragment shader. Input. Normal VS. Not convert. Yes. Okay. Not perfect normals right now. It's almost like we don't get any normals at all. Okay, but we do send them. Okay. So this one right here gives us shit pretty much. And that's because, let's see here, quad. We have mesh dimension and we have height map size. Height map size is 1024, 1024. Mesh dimension 1. What do we have here? Quad, test quad. Test quad size, we do 10 times 10. So if we do 10 and 10, okay. One, we get this. Max height 1. Okay. UV interpolated. I wanna do... Let's just double check the UVs as well. Okay. Yes. This one right here. Looks good. But I reckon that wasn't the only problem. Possibly. No. Okay. One problem less, at least. Up minus right, up minus down, and then cross between those. Should give a pretty good result if we also do... There we go. We have a little bit of... yeah, we have some noise going on here, but we have to remember that for every other center point, let's see here. Every other center point, we don't calculate the normals again, we just interpolate them. Do we actually have the max? So this will hopefully We do selection wire and we go down a bit. So I'm talking about initially, so for this point, we don't recalculate the normal, we just interpolate it between this one and this one, I think. So we can take, so it's probably this point. Yeah, for all of these quad middle points, we don't recalculate normals. Currently. Let's see, if we take this normal and put it into some light calculations, what do we get? Terrain tessellation quad test. Do we have util lighting? So then let's do color RGB. Input position world space, I think we have that. We have clip space. We have normal now. We don't have view direction. We don't have view direction. Ambient multiply specular color. Smoothness, shadow amount. Just do 0.5. 1, 1, 1. 5. 5. We need this one. I wonder where we want to calculate this one. So if we take a look at view direction world space. We need to calculate the view vector. We need to normalize it. Okay, let's do it in the fragment shader. Float. What are we working with? Yeah. Float 3 view direction world space. Position world space, and then I just want to safe normalize it as well. And then we're gonna test this. What's up, Matt? Sorry if this is a stupid question. Is this procedural terrain generation, or is tessellation only about smoothing the terrain? First of all, I'm one of those annoying persons that says there are no stupid questions, or that's the mindset I try to have at least. But as for the question, we are pretty deep right here, right now. So we're definitely doing like custom terrain and generation. our custom terrain is, most of it is decided by a so-called height map. So that's just a texture that has a height value per pixel. We're not doing too much terrain generation here. So we pretty much just generate a height map that is a Perlin noise. What we're focusing on right now, however, is to optimally build a mesh from that data, both performance-wise and visual-wise, and then to be able to tessellate it. So the tessellation is pretty much, we just add more vertices to our original mesh to make it appear smoother eventually. And it's the tessellation that is the focus right now. We need to get it right. I hope it answered your question somewhat. So right now this is just much more about getting a smoother terrain when looking on it up close, pretty much. Yo, what's up, PG King? Yeah, I don't know. My explanation might not do any favors to the complexity of the problem, like making it easier to understand. But like, I'm having a hard time myself trying to follow all the twists and turns we have done here. So initially, so a little bit lore, a little bit background lore. Initially, we were working with our so-called activity texture. It keeps track of where objects are on the terrain, pretty much. With the help of that activity texture, we started developing snow. Turns out there was some problems with how the snow looked. So that's what we're trying to optimize now. We're trying to optimize the mesh that will represent snow to make it look as good as possible. And these optimizations we're doing right now, or improvements, will also be, we will be able to apply them to our terrain as well. That's pretty much it. Okay, so let's see how the shading looks for this one with this. Yeah. Okay, and I want to try one thing here. I have a suspicion that most of the artifacts we're seeing here is from our generated extra points in the geometry shader. So for now, I'm just going to do... Let's try and do this. Improve branching. Let's go to here. And let's see what kind of result we get if we just do this. Append, append, append. Input, input, input. So we basically remove whatever the geometry shader is doing, we just remove it. And whatever vertices we get from the tessellation, we output those. I want to see if we get the same kind of artifacts. We actually do. So we can see here now that now we have this quad-like structure instead of our... So each quad is 2 triangles instead of 4. And we get this disgusting pattern. Which tells me that our normal calculation is probably fucked. But it could also be, let's see here. What do we have from the beginning? We have 1, 2, 3, 4. We have 4 times 4 vertices, and then we subdivide it. We subdivide it. To the power of 5. What is that? That is 2, 4, 8, 16, 32. Okay, yes. Yes, okay. The problem is probably the fact that our UV step length is off. So for each vertex here, we step to the next pixel in the texture instead of the next vertex. I wonder if that could result in what we're seeing here. Yeah, what's up, only element? So you're talking about this one. Honestly, this is just... I tried to get... I wanted good GitHub integration in my VS Code, and you can get some good with GitHub pull requests. This third party, no, it's first party actually. This plugin can give you some pretty cool stuff. I think it can give you issue reference, like we'll reference it like this. Yeah, like this. But it doesn't really give you this view that I want. So what this is actually just Microsoft Edge tools. So what you would use if you were developing web pages to quickly test them. And then I just go to github.com. So it's not that special, unfortunately. It was a little bit of a workaround I found. It works, it works. So I can use GitLab. Honestly, I don't know what GitLab is, but if it's just a front for Git like GitHub, probably. Yeah, you can. You should be able to do it like that. Oh yeah, then you should. Although... I can't vow for the security side of things, but yeah, it should definitely work. So what I'm saying, github.com, gitlab.com should be okay. It's just, it's pretty much a very stripped down web browser inside of VS Code. Yeah, it's probably okay. Okay, so what I think is the culprit for whatever we're seeing here is this one, step UV here. We need to make it we can't make it depend on height map size. We need to make it depend on, or I guess we could, but we need to take this and multiply it with we need to multiply it with something that is like with factors here. No. Okay. I think right now we're doing this simple. So when we tessellate all the edges and insides the same amount. So factors dot edge 0. So let's see here. In the beginning, we have, I think we do a quad like this. And then UV goes from 0 to 1. So our initial step size is 1 divided by 3. 0, 1/3, 2/3, 3/3. And then if we subdivide it once, we get this. So then it's 1/6. So I wonder if we want to do 1 divided by 3 times edge factors. So F. Because here it's 2, so then we get 1/6. Yes, something like that. Let's try it. So 1 divided by 3 times factors edge. Are we still off here? Looks a little bit better. But I can still see... actually, Yeah, the artifacts we can see now are tied to the topology. So hopefully we can fix this. Here we have it. This, I don't know how good it is visible in the stream, but this is what we're trying to fix. So this one has a normal value, this one has a normal value, this one has a normal value, this one has a normal value. So when we color these two triangles, they get... The colorization is very dependent on the topology, so the split, which means that we get like this pattern right here. I don't like that at all. So if we add back the geometry, and we also, this is also important. Let's see. So if we go to 5, it becomes a little bit more apparent at certain points. But if we go over 5 here, we start seeing this issue. And that's because we tell the mesh to subdivide more times, but we don't actually subdivide more times. So yeah, we don't get more vertices, but we get more or finer texture reads, basically. But up to 5 it works somewhat. Except for this. But let's see what we can do about this. This would also be fixed by... if we would be doing... let's do that right now. So if we jump to util normals, if we choose to implement this one right now, we can probably get rid of some of these artifacts. Would like to... I don't want to rely on this, however. But let's see here. Oops. Does this really minimize... Does this really minimize what we send in? Maybe. I just wonder if this will become cleaner. Offset, UV, center UV, 0, step UV. Yeah, it will when we start doing this as well. Let's rename center UV as well to UV. Oh no, did I? Here we go. So down. Right. Left. Oh yeah, we want to get rid of this one. This one. Okay, because what I want to do now is we're going to take all of this high quality, and I reckon we want to do this one, yeah. So up, down, right, left. Let's rename. Something like that. And then we do up left, so minus, plus, minus, plus, and down right. And we have up right and down left. Something like that, I think. And we return left minus right cross with up minus down, and then we do plus cross up left minus down right, and up right minus down left. Let's see what this gives us. Okay. That looks pretty good, although what the hell is happening here? We can actually try. Let's do. Let's add this one back. I would love to see the result if we add if we split quads into 4 triangles instead of 2 as well. I think that would improve it quite a lot. Seeing this as the best... Okay, I know what's going on here. I think... It was up caveman crafting, doing some proc gen terrain. Yeah, in short, I'm trying to improve the visuals and performance of it so we can use it for our snow, terrain, and water as well. Yeah, calculating 8 neighbors is way more expensive, unfortunately. Then we also have this issue. This one might actually... so we're doing view direction per fragment, but we're doing normal per vertex. So if we move this one up to... we can put it here. Output dot view direction world space. Then we do... Still getting those, okay. Interesting. Yeah, calculating 8 neighbors, like if it doesn't look much better than 4 neighbors, we're doing something wrong. But exactly like you say, it's way more resource intensive. Caveman crafting may be good to include a LOD system so that you're only calculating close terrain at a high resolution. Yeah, that's pretty much exactly what we're doing right now. We're relying a lot on tessellation, which is going to be our LOD system eventually. We just want to make it look good, you know, first. Whatever issues we get here, however, sucks. Extremely apparent here by the quad split. Yeah, if we can get rid of that one, it would be amazing. I just want to see... one sec. Let's go with 5. Is it 6? 7, 6 is our most. Okay. And if we would do... low quality... Yeah, low quality sucks with this topology. Although I'm still wondering if we take a look at point where we have the most issue, it would probably be over here. Thought we had some worse. Yeah, we can do it here. I know. Maybe Should be okay. Like, this is 100% some of the issues we want to solve it with this. So this is with 4 neighbors, right? If we do high quality, 8 neighbors doesn't really help much. So the normal for this one is this point, this. Shouldn't we be seeing smoother result here? Yeah, those points, these lines are screwing us. This one takes these into account. This one takes... Okay. I think it's pretty apparent that the result... Yeah, when we're looking at... When the triangle split doesn't happen in the direction of the gradient, that's when we get the biggest lighting artifacts, I think. So what I want to do now is I want to reintroduce our additional split, but we're going to have to calculate some extra normals and stuff like that, but that's okay. Let's see here. So if we go, we're going to split, so this quad right here, instead of splitting it once like this, we're going to split it like this as well. So 4 triangles instead of 2. So we disable this and we re-enable this, which gives us the correct topology, but we don't recalculate any normals here for the middle points. So this one and this actually is... Yeah, it's these ones. So we need to do that. And then we will hopefully get something that looks okay. This actually looks pretty cool, but... Okay, so let's do... We don't want to do lerp here. We don't want to do lerp. We want to do lerp for this one, I think. But then we want to take, for these 3, we want to calculate it from the start. So we want to do position. We want to do I actually want to do all of this again. p1.uv, position world space. It's a little bit too quick, maybe. Okay, we want to lerp this one. No, we don't. Ooh. No, we don't. No, we don't. Okay, a lot of back and forth. We want to do it, but we don't want to do height plus whatever we get here. We want to do position vs.y is equal to... So we want to interpolate the x and z position, then we want to get the y position from t height. P1 UV, like this, and then we do this. But P1 dot position world space, P1 dot position lip space. Interpolate x and z and y, but we don't care about y, we throw it away here. And this. And then recalculate the normal as well. Height map. But then we need to calculate this one and this one again. Let's see. Okay, we're gonna do it like this. The only problem being that we don't have access to, so if we take a look at how we calculate step U and how we calculate step UV, we use factors edge here. We don't have access to this one down in the geometry shader. So, I have to do Let's do a quick fix. We do float to UV step. Right now we do the assumption that all of these have the same step UV, which they are not going to have when we do more dynamic tessellation. But yeah. Is dimension step UV, I think. Okay, I don't care about that. Step UV, what did I call it? UV step. UV interpolated here as well. What we have instead is Q1.UV. Okay. Yes. Okay, so the position here in the center is fucked. What performance do we have? I love this. So this one right here doesn't seem to be working. P1 UV. Yeah, of course we need to. Nah. Really? If I do 10, then we get this. Odd, we have, okay. So if we position this one at 0, we want to do object space. Okay, we still have the grid like normals. How is the... I think we get individual heights for these. It's just that the normal gets screwed up. So this one. It might actually be this one. And we're gonna try one more thing. We definitely get another offset here. Okay, so we have to work better with the sync between underlying texture, dimensions, and world dimensions. We want to... So the less we subdivide the mesh, the lower we want to go on the MIPS level for the terrain, pretty much. It doesn't do us any favors, but then again... Then again, if we would be doing... Let's see here. What I want to do is... Initially, whatever... This one right here, the value right here. I want more control over this one. I think... Yeah. Basically, let's see here. or I want to specify this one rather. I wonder if we can do that by doing our initial mesh is four vertices, 4 times 4. Add what we have, 12, 256, 128, 64, 32, 16, 8, 4, 2. 0, 1, 2, 3, 4, 5, 6, 7, 8. So when we read this initially, we read it from a MIP level of 8. 1, 2, 3, 4. It looks pretty good. Okay. So we want to read it from, let's see here. Eight initially. Divided by, we can do it divided by, but we can do minus round two. Factors.edge 0 divided by 2. So if we have a factor of 2 here, We get 1, we get 7. We move up 1. If we have a factor of 2, 4. 4 divided by 2, 2. So we move up 2. Maybe something like this. But I fucked up. It's this one we want to change. We don't get any cleaner result than this. Yes, we need to do util normals. um, really? Okay, so we do get the dynamic level change here. I wonder why. Yeah, we don't get peaks here. Okay, that's good. Hmm. Okay, because we still do this one. I think the error lies here or here. I'm pretty sure that's the case. The normal for this one, we pretty much take this full plane. One sec. Actually, it's way less apparent here. I like way less. This actually looks pretty good. This actually looks really good. Interesting. Okay. There's one tiny mismatch until I'm content with the normals, at least. And then we're gonna have to fix it with the additional middle point vertices as well. Yeah, we're gonna continue this experimentation tomorrow because I gotta run. But I'm still very much optimistic about splitting quads into 4 instead of 2. Pretty much no difference in performance, but we're going to be able to clean up some of the worst artifacts we got with the snow. Yeah. Thank you so much for watching, everybody. I appreciate it. Hopefully I will see you tomorrow. Have a great rest of the day. Peace.